streaming. So we're recording right now, and we should be live streaming very soon. And as soon as we begin live streaming, I'll begin the proceedings. We'll see. Okay. All right. We should be live streaming on Facebook now. I want to welcome everybody to the Ambassador Lecture Series. And this is the second in the series this academic year. We're very happy to have everybody joining us online. And safely distanced, which is a good thing. With no further ado, I will discuss the lineup for today's event. We will begin with an introduction by Dr. Lutfi Al-Sharif, and he's officiating on behalf of the University, Al-Hussein Technical University. Dr. Sharif is the Dean of the School of Engineering Technology. Thank you, Dean Sharif.
Thank you, Dr. William. Thank you very much, and thank you for all your efforts in arranging this. I'm delighted today to welcome His Excellency Ambassador of Japan, who's with us, and we are very, very excited to have Professor Hiroshi Ishiguro with us today, who is a world-renowned scientist and researcher in the area of robotics. I am very excited personally because I have seen Professor Ishiguro a number of times on the BBC. So I think this is a great opportunity for all of us to listen today and learn about this exciting subject. And I just want to say a couple of things about Jordan and robotics. Robotics is a field which is developing and flourishing in Jordan, and we have lots of schools now and at the university level, at the school level and university level, where there are lots of courses in robotics. The other thing I wanted to say as well is that drones are becoming very widely used in Jordan. There are a number of private companies who have very advanced capabilities in terms of using drones and solving a lot of civilian and other problems in there. So I think Jordan is at a level where we are still developing, but I think there's a lot of promise in what is happening in there. The third thing I just want to mention is that we recently had a very, very successful sumo wrestling sumo robot competition between various universities, which was hosted by HTU, and then it was then hosted by the Princess Sumaya University of Technology. So there's a lot of excitement in Jordan among school children and in universities about the potential of robotics and drones in public life and in solving problems. So I welcome you all to this event, which I think will be a successful and exciting event. Over to you, Dr. William.
Thank you, Dr. Sharif, for your comments. And now it is my grand pleasure to introduce His Excellency Ambassador Karu Shimasaki from the Embassy of Japan, who was our first lecturer this year. Ambassador.
So thank you very much, Dr. Williams. Dr. Sharif, Dean of Technical Engineering of Al-Hussein Technical University, and Dr. Ishiguro, Professor of Osaka University, distinguished guests and listeners. It is our great pleasure to hold this online seminar on robotics in cooperation with Al-Hussein Technical University. This is the second opportunity for the University of Japan to co-organize events with HTU in just 4 months. I'd like to express my sincere appreciation for HTU's continued support for the embassy's activities. Ladies and gentlemen, this time the topic is robotics and its research frontier. We are honored to have Dr. Ishiguro of Osaka University, one of the world's leading humanoid robotists, as a lecturer today. He is a professor of the Department of System Innovation in the Graduate School of Engineering Science and visiting director of Hiroshi Ishiguro Laboratories at the Advanced Telecommunications Research Institutes. His research team are mainly working on development of robots with human appearance as a part of his efforts to realize the vision of creating an intellectual system that supports a future society of humankind. As all the listeners today are aware, robotics and AI are keys to depict and build better future in our age. It would be great to see young Jordanians interested in the topic through the lecture today by one of the greatest scholars of the world in the field of robotics. I'm sure that lecture will greatly inspiring students in the field of engineering in their future researches. Ladies and gentlemen, moreover, it would be worth mentioning here today. Every year, the Embassy of Japan selects 4 to 5 Jordanians as governmental scholarship students. The selected students will be given full scholarship to get degrees in Japanese universities with excellent professors and curricula. The application for the next batch will open from next spring. So if you get interested in the advanced researches in Japan, represented by the works by Professor Ishiguro, I would like to recommend you to check it out to realize your potential in Japan. Finally, let me reaffirm our keenness to strengthen cooperation with Jordan in many fields, especially in science, academia, and culture. We will continue making opportunities for Jordanians to know Japan in its diverse aspects and strengthen ties between our two countries. Thank you very much for your kind attention. Thank you.
Thank you, Ambassador. And with no further ado, I present to you today's honored guest, Professor Hiroshi Ishiguro. Thank you, Professor.
Okay, may I start my presentation?
Yes, yes.
Okay, so let me share the screen. For everybody, thank you for the kind introductions. This is my great honor to give a talk in this seminar. Let me share my screen. Where is it? Just a moment. Okay, this one. So I think you can see my slide, right?
Yes, we can see it.
Okay. Okay. So today's my title is Interactive Robot and our Future Societies. I'm a professor of Osaka University in Japan and the visiting director of ATR Hiroshi Ishiguro Laboratories. And the more important things is I'm a project manager of a moonshot project. This is the biggest Japanese research grant. The purpose of this grant is to realize the avatar symbiotic societies. I'm going to talk about the avatars in the end of my talk. And in addition to that, I'm a thematic project producer for World Expo 2025 in Osaka. You know, this is also the very, very important activity for me that I need to represent. I need to build my own pavilions for representing our futures. So what kind of a society, what kind of a city, what kind of a technologies that we're gonna have after 30 years, right? And maybe after 30 years, after the 50 years, right? So so now I'm working with my team members for preparing the exhibitions in this, the World Expo 2025 in Osaka. So I strongly hope you visit this World Expo, in 2025, just after the 3 years. Right? So what I want to create in the future is this kind of human-robot symbiotic societies, as you can see here, right? And the robot is supporting the human activities people's activities in the daily situations. So this is our future, I believe, especially in Japan. Our population is going down to the half of the current populations. Right, and as you know, the Japan, it is not so easy to invite the foreign people. I mean, you know, well, our situation is different from your countries, the European countries, right? And not so easy to accept the foreign people as a worker, right? But our solutions, our possible solution is to use more robots. And you know, especially for the robot technology is very convenient for example, for this kind of you know, the recently we have a big problem about coronavirus, but you know, if we use the robot for the interactive services, you know, we don't need to worry about the coronavirus, right? So you know, we can have a more the safer solutions, you know, for social service. Okay, so the 20 years ago, I got this imaginations, you know. I started my career in robotics 30 years ago, and in the beginnings, I studied about the autonomous driving system and computer vision, right? And then, you know, I have decided to create the interactive robots to support the human life, maybe after 20 years, right? So at the moment, in robotics, we didn't have that kind of research, right? You know, if we say the robotics, always the people research navigations, it's an autonomous driving system, and the manipulations. Manipulation is for the robots that works in factories, right? The manipulators actually, right? But you know, I wanted the I have developed a new research area in robotics that is called the interactions. In the interaction, we are studying and developing the interactive robot, and you know, studying about the human-robot interactions. I have started my research with the mechanical looking robot, and then, you know, I have developed the many kind of human-like robots, the cute robots, some baby-like robot, and very human-like, you know, the robots. This is a robot, but this is not robot, right? And this is a robot, and this is not robot. But so anyway, so finally, I have created my own copy. Okay. So why this question is very important. Why do we need humanoid robots? The answer is not so difficult. It's simple, right? Human has a brain that recognizes humans, and the ideal interface for human is humans. Therefore, the information media devices such as the talking rice cookers, they should be at least partially human-like. And conversely, to understand humans, very human-like robots, it's called the android, are needed. Okay. And the we are taking the by using this very human-like robot android, we are taking a little bit different the approach for the science. So we call that approach in a constructive science with intelligent systems. The past brain studies have found that human intelligence comprises elements of memories, computation, inference, learning, etc. So the challenge is to identify how these elements can be put together for realizing a human intelligence. And the constructive approach, constructive science, will reconstruct the robots and androids to model humans and use such robots and androids to study the human macro level functions. Right. So, for example, what is the macro level functions? Consciousness, or heart, or the mind, or, you know, emotions. These are, you know, very more complicated function of humans. So that is the macro level functions, and it's quite difficult to understand that macro level functions based on the neuroscience and the cognitive science. Okay, so it is not so easy. Of course, it's probably possible, but it is not so easy. Another approach is to use the intelligent robot, humanoid robot, or android as a test bed. Macro level of their functions. So this is our approach. We are developing the very human-like robot based on the knowledge about the the humans and the knowledge of technologies, okay, and then by using that robots, very human-like robots, we are studying the macro level, the cognitive function of humans through the interactions, through the interaction between the human and robots. Okay, I hope you could understand my ideas. So if we look at the technologies in robotics, so far we focus on these some fundamental things in mechanics and manipulators and sensors and image understanding and voice recognition. Thanks to the deep learning, we could have human level image understanding and voice recognitions. However, we don't know what intelligence is, right? And still, this is the open questions. Okay, so the current deep learning is very different from the human brain, brain functions. Okay, for example, in order to understand, okay, let us think about to understand the cat or dog, right? So how many pictures we need for understanding the cat or dogs, right? Usually humans, we don't need to have so many pictures. Maybe the 10 pictures is enough for learning what cat is, what dog is, right? So if we show a couple of pictures to the young infant and the babies, right, they quickly recognize the cat and the dogs. But for the AI, the current AI, the deep learning need to have huge number of pictures, maybe 10,000, 100,000 pictures, right, to understand the cat and the dogs, right? So what I want to say, the current deep learning is totally different from the sophisticated human brains, right? And we don't know what intelligence is. Okay, so after this, by using the advanced technology of a deep learning, we can we can deeply study about the human intelligence itself. Therefore, the intelligence is a very important research topic. So intelligence is, of course, this is a kind of macro level or meta level cognitive functions. And then embodiment means the body properties. So in order to have experience, we need to have a body, right? Body and the sensations. So by using the body and sensations, we can have a very rich experience. Then we can run a lot of things in a real environment. Unfortunately, the current AI doesn't have a bodies, right? So we need to give a bodies. Body means a robot. So the AI need to have a robot bodies, and then the AI can have own experience, right? So that is the issue for the embodiment. And then the multimodal integration. We have a good technology for the voice recognitions and the image understanding. And however, we are, we humans, we are using the several modalities simultaneously, right? In order to understand some things, we can see, we can touch, we can hear the sound, and we can smell, right? So we are using many modalities for recognizing the object and for recognizing some other things. So the multimodal integration is a very key the features of human sensations, right? So and if we I really think like this, right? So we have a multiple modality, therefore we can quickly run so many things. Okay, a single modality is not enough for the rapid running, but if we combine several modalities, we can quickly run many things. So therefore, this is also the very important research issues. And then the intention desires. Intention desire, this is also the very important. So we need to give intention and desire to our robots. So but basically, what we want to have is a autonomous system, right? So everybody want to have an autonomous driving system in the very near futures, but the autonomous system need to have a decision-making functions. So what is the decision-making function? How we can do that? So if we look at the human has the intention desires, and the intention desire, behaves like a decision-making systems, right? So the point is we need to give the intention desire to the robot if we expect the robot to become fully autonomous. So of course, we cannot give wrong or bad intention desire to the robots, right? So we need to carefully design the intention desire for the robots. But once we give the intention desire to the robot can be fully autonomous. And then we may feel the consciousness through the interactions with a robot, which has the intention desires. So consciousness is one of the very important research topics for the next decade. There are so many approaches about the consciousness, right? The computational approach or psychological approach, and some approach from robotics. Okay, but I really think the consciousness is very important research issues. Okay, and then so if we could understand what consciousness is, we can make a more human-like robot, and we can have some friendly relationships with AI and robots. And then we may have we relationships with AI and robots. So if we can feel the consciousness in the interaction with the robot, of course, we may accept the robot or AI as partners or the friend, right? So then, that we can have social relationships with the robots and AI. So this is the, my current research. We are tackling to these fundamental, difficult issues. These meta-level cognitive functions of both the human and the robots, right? So we are trying to understand these functions by creating the very human-like robots. And of course, we have a kind of a roadmap for robot development. Now we are focusing on the robot which has the single human-like functions, but the final goal is to develop the companion robot which has the multiple human-like functions. Okay. So I'm going to show you several practical robots later, but anyway. So intelligence, embodiment, and multimodal integration, these are fundamentals. And once we can implement the intention desire to the robot will become the very human-like robot. And then, we may develop the companion robot that can pass the multimodal Turing test. Okay, let me talk about the multimodal Turing test. Of course, so I want to say, that we want to have a challenge to the total Turing test. The total Turing test is like this. I believe, and everybody knows the Turing test. The Turing test has been proposed by Alan Turing, right? And so in the Turing test, we are comparing the chatbot operated by human operators and the chatbot operated by computers, and the users are talking with humans or the computers, and by using a chatbot. Chat system, SNS, right? So if the user cannot distinguish which is which, the operator is humans or the computers. If user cannot distinguish, right, then that computer we can recognize that computer has a human level intelligence. So if we say the total Turing test, that means that we want to evaluate human likeness in all modalities. Okay, so suppose we are talking with the Android, very human-like robot. If we cannot distinguish the Android with humans, so that the Android can pass the total Turing test. But unfortunately, it's almost impossible to develop the perfectly human-like Android. If we have maybe the 10-meter distance, I think it's quite difficult to distinguish the Android, the human, the real humans. So we have a pretty good technology for developing the very human-like robot Android. But however, if we carefully watch the detail of the androids, we can easily distinguish which between Android and the humans. But however, still we can have a pretty good we can have good relationships with the robot, right? We can enjoy the conversation with the robot, and so this is not perfectly human-like Android. This is the cute interactive robot, but this appearance is enough for having the rich conversations. Okay, then when we have defined another type of Turing test that is called a multimodal Turing test. So in a multimodal Turing test, we compare between robots manipulated by human operators and autonomous robots controlled by developed technologies. Okay, so we are comparing the avatars and fully autonomous robots. Okay. And if we cannot distinguish which is which, so we can recognize that this computer program is, equal to the human. Okay, so this is the multimodal Turing test. So the multimodal Turing test evaluates the total human likeness through all of modalities and evaluate the social acceptance as the member of a society. So this is the the goal. This is our goal. Our goal is to pass the multimodal Turing test. Okay. So let me show you the our most advanced our technologies. So as I said, we are studying these fundamental issues, and in this challenge we are focusing on the almost all fundamental issues, 5 fundamental issues. So our challenge is to develop the conversational autonomous Android. Okay, and the in this project, the most important challenge was to implement the intention and desire to the Android. Okay, I know what is the intention desire, right? So if we check the the papers and some textbooks of humans, right? So we can easily find this kind of complicated architectures of human intention desires, right? So the young infant, the babies, they don't understand the own desires, but of course they are behaving according to the embedded desires, right? And then after growing, right, we recognize our own desires. Then we can take the kind of a top-down approach. So we recognize desires and choose the intention. The intention choose the behaviors, right? And if we consider, if we think about the human developmental process, the intention desire is the system for the intention desire is very complicated. But if we look at the adult, we have we know about our desires, and then we can choose the proper intention to satisfy the desires, and we can choose the behaviors, for satisfying the intentions, right? So this is a very simple hierarchical approach, and we are following this approach for developing, for implementing the our Android. And this is the system architecture that consists of many subsystems. And then this is the interaction composer. This is editors for our Android. We have developed the graphical editors for developing our Android. And in addition to that, we have developed so many subsystems to make the Android the human. I believe you can hear the voice of this Android, Japanese. This technology is very important for making the Android human-like. So we are sending just a voice to the Android, and Android is analyzing the voice and generating a lip movement and head movement and gestures. So now I'm talking and I'm moving the lips and head and to hands, but I'm not intentionally controlling these things, right? My brain, probably my brain subsystem, autonomously generating the lip movement and head movement and gestures. So we have implemented that kind of the function to this Android, right? So that is a very important.
ご飯を食べに行こうっていう話になって、でどこに行こうか結構迷ったんですけど、結局
I think you could hear the Android say so this is the nodding, and so Android said yeah I know something like this, right? So this is the function for the attentive listening. So and actually Android is not recognizing the human voice, right? But however, Android can continue the conversations by nodding, by saying the yeah, I know, something like that, right? So this attentive function, listening function is also important for continuing the conversations.
ただ、その勉強って本当に必要なのかなって思うんです。
いや、絶対に必要になる部分は結構出てくるとは思います。
So here, there are two Android and the interlocutors. They are talking simultaneously. Then Android is saying that, may I speak first, right? So this kind of the Android need to avoid this kind of speech collisions, right? And this is also the important, but a little bit difficult the function to implement. And then we have selected two desires for the Android, the personal desire and the social desires. We have tested the many kind of desires. And then, finally, we reach to these solutions. So as the personal desires, the Android need to have their desire for building the relationships. And as the social desires, the Android need to have a desire for qualifying the relationships with others. So the task of this our Android is to speak with the visitors. Android is sitting in the lobby of our research institute and talking with the visitors, the newcomers. Okay. And when the Android is talking with the visitors, Android does not need to have a deep conversations, but the purpose is to exchange the the casual informations and to know each other, right? Therefore, such kind of purpose, these desires works very well. And then this is the total system of our Android. So and this Android has the many functions that can find in the human brains, right? And our system is very different from the human brains, but our system is following the brain structures in some sense, right? And the many modules are corresponding to the brain functions. Okay. And then, I think today I don't have enough time to explain the details. And this is the conversational topics that Android can handle. So actually the Android, they can talk about the 150 topics, right? So this is, I think, you know, the good number, the huge numbers, and comparing with young people, right? So they are probably the Android can talk more than the young people. Right? So this is the result. This is the Android with created.
よろしくお願いします。
それで落合さんは
But
春は好きですか？
春好きですよ。あったかいし好きです。
そうなんですね。私も春は好きだからなんか嬉しいです。
そうですね。
やっぱり春の桜は綺麗で良いですよね。
そうですね。綺麗だし。
So, and if you access to the YouTube, so, you know, you can download. It was a keyword of Erika and my name is Ishiguro and Android. You know, you can download the many the footage of this Android. And you know, this Android is everything's the artificial. The voice is also the you know, synthesized voice, okay, and the behavior and the gesture, everything, and synthesized. In addition, and the Android has the internal state. Mood and likeness, right? So mood is you know, own mood, right? So exciting or not, or something like that. And likeness is the likeness to the interlocutors. Android is simulating two parameters, and at the same time, Android is evaluating the interlocutor's mood and likeness. The blue graph is the Android own mood and likeness, and the red graph shows the interlocutors, humans, the mood and likeness estimated by Android. If Android estimate their mood is getting better and they are liking each other's, then in Android, you know, they consider, you know, relation is getting better, right? And then Android proposed to talk about the more personal things. So anyways, Android is behaving, interacting with the humans, the visitors, by according to these internal parameters. One more time.
もともとご出身どちらなんですか？
出身は奈良県です。
あ、そうなんですか。谷口さんは奈良出身だと関西弁ですか？
あ、私関西弁です。
じゃあ、やっぱり関西弁の男性の方が好きですか？
それはそんなことないかな。
あら、そうなんですね。じゃあ、どこの方言が好きですか？
So this conversation is quite natural, right? And then, you know, we have invited 25, let me see, the 25 people for testing this Android, the human likeness. That we perform the multimodal Turing test. You know, half of them, you know, they said that probably this Android is, you know, controlled by human operators. Actually, you know, this is not avatars. You know, the computers is controlling and controlling everything, right? But half of them, they said that probably this Android is controlled by human operators, and the 5 of them. Right, the 5 over 25 people, they said, and I'm very sure that this Android is perfectly controlled by, you know, human operators. That means that, you know, this Android could pass the multimodal Turing test for the 5 people, right? I think this is, you know, the good result, and this result shows the quality of this Android human likeness. And actually, you know, the people, subjects, almost all subjects could feel the emotions and the consciousness and some intelligence through the interaction with this Android. So we can attack to this very difficult question, what is emotion, what is consciousness, what is intelligence by using this Android. This is the constructive science, constructive approach for understanding the humans. And of course, same times we can develop the more human-like robots. Okay. I have spent 30 minutes, and then and I want to talk more about my research project, but today I want to introduce my activity for the World Expo 2025. But before that, let me introduce one more Android. Okay, the problem of the adult Android, adult level Android, but it's so difficult. Therefore, we needed to limit the situations and the task of Android. Always Android is sitting in a lobby of a research institute and talking with, having the casual conversation with the visitors. Right, we needed to limit the situation and the purpose. Right, the question is how we can develop the Android that can work anywhere, that can talk with any kind of people. Our solution to develop this robot childlike Android. So this, the childlike Android is this is also the very the human-like, and if we give the childlike appearance to the Android, the merit is the Android can ask any question, any kind of a question to the people, right? So this is a child, and we humans, we are very kind for the child, and well, our purpose, our new project is to develop this, child Android and develop the new research areas for the socially developmental robotics. Okay, so this Android is interacting with many kind of people and gathering knowledge, developing their own intelligence. Okay, sorry, one more video. So this is my campus, right? My campus, and the robot is always moving around in my campus, and I think that this is a kind of futuristic scenes, but this is the usual scenes in my campus, and I hope to deliver this kind of robots in the world, and I hope people have a good relationships with robots. So by using these technologies, what kind of features we can create? So let me talk about the World Expo. I'm the thematic business producers, and I need to create the my own pavilions. And after 3 years. Now, the Dubai is running the World Expo. It's our turn. Okay. So the designing future societies for our lives. So human life, that is our main theme. The 50 years ago, we had the World Expo in Osaka. This was the very successful of the World Expo. At that time, we were sharing the the single the features, 50 years ago, everybody was expecting to have highly developed technological societies, and we are crazy for developing new technologies. Okay, but what happened after 50 years? We could develop so many kind of technologies already. Okay, and then the more important things is we humans, we are designing ourselves by using technologies. For example, the gene manipulation technologies. Okay, and then we are controlling almost all things, and we are quite interested in ecosystem, and not only for the human society, but also the animal societies, for everything. Okay, so that means we are designing our environment, and we are designing the human itself by ourselves, right? So so we need to design our futures. So that is our important role, and so okay. So we didn't consider 50 years ago like this, right? We were just crazy for the technologies. We didn't care about our world, our environment so much. But today's we care so many things, and we are trying to control everything by ourselves, right? So then I think if the future design is our role, we have so many different values, the different ideas, different the ideas for the happiness. Okay, we have diversities. Okay, we the diversities are very important, right? So, but so that means the future is not single, right? So we can consider there's so many types of features. So what kind of features we can have after this, after 50 years, right? So and we need to answer to these questions in World Expo, right? So my mission is to create the pavilions that represent our futures, what kind of future life we can have after 50 years. So that is my pavilion's missions. So how the human can have more evolutions by using the technologies and science, right? So we're gonna use the more technologies for supporting our bodies, and we may use the brain-machine interface for supporting the brain activities, okay? And this is the artificial heart, right? So this is also our possibilities. We may replace our natural organs with machines. Okay, and then we may use the technologies for editing the genes, right? For manipulating the genes, so we can design ourselves. Okay, and on the other hand, the robots and android is going to be more human-like, as I have shown today, right? And we may in the Android, right? So we may build the social relationships with human-like robots. So we may see that there is a possibility. We may find the human-like, the heart or mind in the Android. So robot is going to be a human-like, and on the other hand, the human is going to be integrated with the machines, with the technologies, and the human is going to be more a kind of a robot-like, right? So boundary between the human and the machines disappears. That is our futures, okay? So I want to represent our futures by using our robot technologies, our technologies for, so we have many technologies, and artificial intelligence technologies, the mechanical engineering technologies, so many technologies we have, right? So by using that kind of technologies, I want to represent our features in the World Expo. Okay. So in addition to that, I want to exhibit the futures of humans. So, after showing some futuristic scenes, in the pavilion, the last exhibition is the human evolutions after 10,000 years, or probably more than that, 10,000, 100,000 years. And how can we have evolutions, right? What kind of the humans we can have, right? After 10,000 or 100,000 years. So nobody knows that, right? Probably we may use the more technologies for our bodies, and we may have some direct connections to the internet by using a brain-machine interface. But I want to represent something like that, right? So anyway, mission of my pavilion is to represent the amplification of lives by using technologies, robot technologies, some many related technologies, and our future life. So, and in addition to that, we're gonna use the many avatars. So, so the avatar is, the another important issues. As I'm running the big project. It's called the Moonshot. This is the biggest project in the Japanese government, right? By 2050s, so we're gonna realize a society in which people are free from the constraints of body, brain, space, and times. So that is called the Avatar Symbiotic Society. Okay? So more concretely, we want to create this kind of future societies. Anyone, including the elderly and the people with disabilities, will be able to freely participate in various activities with abilities beyond ordinary people, while expanding their physical, cognitive, and perceptual abilities using a large number of avatars. So anyone will be able to work and study anytime, anywhere, minimize commuting to work, and have plenty of free times. Okay, so this is our future society. Maybe probably already we have started this kind of a society already. So Metaverse is it's a virtual societies, but the people are using the avatars there, and I think that we want to use the robot technologies, and we're going to use the avatars in a physical, real societies. So how we can have sustainable or more robust World Expo against the coronavirus. The solution is to use avatars, right? So, but if we use the robot avatars, computer graphics avatars, the people can attend to the World Expo from everywhere, right? And the people can walk in the World Expo. And after the World Expo, I strongly to expect to have human avatar symbiotic societies. And another important meaning of a human robot symbiotic society is we're going to have more chances to think about humans. What is the emotions? What is intelligence? So if we interact with robots, the human-like robots, we're going to have many chances to thinking about humans, because androids and robot is a mirror to reflect humanities. So this is our features. Sorry, actually I have many topics to speak, but today's talk is I have just a limited time, and But I hope you could understand my basic strategies in robotics and my more ambitious challenge in World Expo in 2025. So thank you for your attention.
Thank you, Professor Ishiguro. Thank you. This was such a fascinating talk, and we are so very appreciative of your time to learn about your research and your efforts in the field of robotics. I would ask the viewers if they could please, the ones on Zoom, if they could please post their messages in the chat rather than raising your hand. And for the folks on Facebook, I will be receiving a feed for questions from my assistant, Lean Al-Jadid. So the first, let's see, we have a few questions here. What is meant, Professor Ishiguro, by a humanoid robot?
Okay, so we have many types of humanoid robots. Okay, just a moment. Wait, okay, so let me show you some pictures. Okay, so here we have many types of humanoid robots, and of course this robot, this is made by plastic, right? And this is the combination of plastic and some metals, right? And but for this android, very human-like robot, we are making this android by using a silicon. Silicon is a very stretchable material, and pneumatic actuators. We are not using a DC servo motors. We are using a DC servo motors for this robot, but for the android, very human-like robot, we are not using the DC servo motors. It's pneumatic actuators. It's air cylinders. Because the DC servo motors usually make noise. But if we what is the most important features of a life-like android? When I'm moving the hands and here, right? But there is no noise, right? We cannot hear anything, right? This is a very, very important. Therefore, make the robot human-like, right? Therefore, we are using pneumatic actuators. Okay.
Great. Can you let us know what industry is robotic use most used in? What's the most highly used industry for robotics?
Of course, so probably the question is which company are using this kind of interactive robots, right? So unfortunately, the market of the interactive robot is not so big, right? And we have a kind of a toy companies. They are selling these small robots and the conversation robots, right? In Japan, if you check the Japanese companies. But you can just Google the keyword robot in Japan. You can see so many toy-like robots. So unfortunately, the current main market is a toy, right? But especially for the coronavirus situations, it's quite important to replace the human labors with avatars. Okay, so we don't like to put a mask, and we don't like to worry about the coronavirus, right? So if we use a teleoperated avatar, teleoperated robots and androids, so we can have more freedom to work in real societies. So now we are trying to do that. So last year, I have started my own company. My company's name is Abita. So the mission of Abita is to develop the avatars, teleoperated computer graphics agents and robots, for supporting the human activities under this coronavirus situation.
Okay, and so I guess maybe it's important to differentiate between humanoid robots that interact with people and robots that we use in industry as well. Is that correct? Because I believe we've been using robotics in industry for quite some time.
Yes, of course, well, Japanese factories, almost all robot factories, right? We are using a lot of manipulators, right? And that is, of course, the main market. But now I'm talking just the interactive robot, human-like robot. So now we are trying to develop the new market with this, interactive robots. But of course, we have a huge market for the industrial robots and manipulators, as you know.
Okay. What is the use of the microcontroller in robotics?
Of course, we need to have many computers, right, for controlling the very complicated robots, right? So, well, we are just using the so many computers, right? So many small computers, and they are big computers for the voice recognition and the image understanding, right? So it's the collection of computers.
Okay. How far do you think we are from developing a conscious robot that knows, let me see if I just lost it.
Yeah,
that knows and he exists and starts kicking in the survival instinct?
Yeah, well, there are so many levels, right? So, and if we limit the situation on the purpose, as I have shown in this talk, the Lإلقاء is my Android, the people can feel that kind of a consciousness through the conversations. But we need to limit the situation on the purpose, that we cannot have, general their consciousness yet, right? And that is going to be a big challenge. I don't know when we can solve that kind of problems, but now the conference for the consciousness is getting very active, right? And the many kind of people they're coming from the many kind of research areas, and we are actively discussing about how to solve that problem. And unfortunately, I cannot give you the I cannot tell you when we can solve the consciousness. But
well, a follow-up question to that is, what do you think the obstacles are to achieving that? What do you think that? Yeah,
I think I think one of the obstacles is and how we can simulate the human-like brain. The functions. The deep learning is not, it's so simple, right? It's just a big neural network, but we have so many subsystems in our brain, and subsystems is interacting in the very complicated ways, right? So the first of all, I think it's we need to simulate that kind of a human brain, the modules, the brain functions, by using a current neural networks, and then we may find the what human-like consciousness, right? And so I think that is one of the important research approach.
All right, awesome. Do you think this is a question from Dean Spieb? Do you think it's possible to let's see, of a combination of human with a disability? So if we think about humans who have disabilities, do you think there is a way to embed robotics into their neural system to overcome those disabilities?
Yes, of course, that is a very, very important approach. Right, and the disabilities, and do you know the ALS? ALS is the person who lose their control over bodies, the muscles, right? So now we are working with neuroscientists. It's the medical school. The Osaka University, the medical school in Osaka University, they are developing the brain-machine interface for that kind of, the handicapped people, right? And we have, they have developed a very small small devices, and they are embedded in installing that devices in human brains, and the devices, they are reading the brain signals and sending some stimuli to the human brains. That is a communication tools right? Then, you know, we are planning to connect that device to our Android, right? And that patient is, you know, going to lose the control of the bodies, but by using the Android, you know, that patient can do something, you know, in the real world. So I hope we can show that kind of a demonstration in a World Expo. In a World Expo, I hope, you know, that patient, they can have a kind of, you know, job.
Right. Do you think it would be possible for us to mimic the human brain at some point so that we can build the same number of neurons and connect them the exact same way? Basically, you know, can we recreate consciousness?
I think it is quite difficult, right? But you know, recently I'm working with people from the quantum computing. So one of the possible application of quantum computing is reservoir computing. Probably you know the reservoir computing. It's a kind of neural network, very complicated you know, neural network. So the quantum computing is good for simulating the reservoir computing, right? So reservoir computer has a very similar the phenomena to the human brains. Okay, so you know the researchers, they considered, you know, human brain is a kind of a reservoir computers, and they, you know, and for realizing the huge scale of reservoir computer computings, we can use the quantum computing, right? So I think that is a possibility. It is not so easy to develop the very complicated human-like brain computers, right? So that's going to be very huge, right? But if we can develop the quantum computers, right, and if we can develop the reservoir quantum computers, you know, there is a possibility to simulate human brain.
Right. So as we would develop, so let's say we're able to develop and move forward in a symbiotic society where humans and androids are interacting on a daily basis and are you know, interacting on a number of, you know, in a number of ways. What are the ethical consequences for such a society? So as you know, we could ask two questions, right? First of all, what are the ethical consequences? But then, you know, what are the as androids approach a consciousness, you know, what are our responsibilities as humans?
Yeah, so human robot symbiotic society, probably after 30 years, 50 years, we may have that kind of the societies. The important thing is that we are going to have a different ideas about the human or robots, right? So today we consider the robot is not humans, but if after 30 years, after 50 years, if you know, if robot could have a human-like heart and a mind, we may accept the robot as a human. So that is a possibility. We may have a totally different ideas about the humanities. So the one reason is, you know, think about the handicapped people who doesn't have arm and legs, who are using the artificial hands, artificial arm and legs, okay? And who has the artificial organs. Are they losing the humanities? Right. So look at the players in the Paralympic games. They are using the artificial legs, and you know, but they are not losing the humanity at all. Okay, so we don't care about the flesh body already, right? We are just accepting the mechanical bodies as a human bodies. Okay. So even if I replace the almost all bodies with machines, so that means I'm gonna be a robot. But still, you know, if I have a human-like heart and a human-like brain activities, I can be a human. So that means a robot can be a human. right? If we have a very sophisticated human-like the brain functions, if a robot has that kind of human-like brain functions, probably we're gonna accept the robot as a human, right? We cannot define the human as a flesh bodies, right? As we are agreeing today, right? We are accepting that kind of ideas already, right? So, so then, I think, boundary between the human and robots disappears. The more important thing, we're gonna have a different definition about humans. We never defined humans with the bodies, right? So we define the humans as the, how can I say that, some, the information process, in the brain.
Right.
I guess so.
Right. Well, so the follow-up question to that is then, as we advance, we have this symbiotic society with androids. At what point does that relationship no longer maintain symbiosis, right? So at what point do the androids are no longer symbiotic with humans?
What do you mean that always, I think, we are creating the Android, right? Android, and we never developed the bad Android, right? Always we are, so, today, think about today's life, we are using a lot of technologies, okay? And we and then always we are developing the symbiotic society with the technologies. So technology is the most important for the humans. That is different from the animal. Animal doesn't have a technologies, but the human has a technologies, and we have another way of evolutions. So that is the technologies. Okay, so we cannot separate the human and the technologies. If we separate, we lose the definition of a human in some sense. Okay, therefore, always we coexist with Android and robots. I'm not sure I could answer to your questions, but
I think what the person was asking was, if we develop a symbiotic society, right, where we're relying on androids to help us go shopping or drive the car for us because we don't like to drive, or to do various things, as the let's say the consciousness of the android becomes more and more sophisticated.
Okay.
At what point do we say, okay, the android is no longer kind of a machine that I can,
I think Android is going to be a human.
Okay. We have how advances in learning and learning and machine learning impact is of particular interest to me. I'm a linguist, and so I'm very interested in language and mimicking.
Yeah, I think the conversational function is very, very important for the human-like robot. And always this 10 years, I was working with the researchers from voice recognitions and the speech synthesis and some natural language processing, and because of their thanks to their technologies, the robot could be a very human-like. We could give a very human-like conversational function to our Android. So it's quite important to work together. But on the other hand, they don't care about the bodies, language, and the the head movement and the gazing control, right? they are not so good for that. Non-verbal, they don't care so much about their non-verbal communications, right? But the non-verbal cue is also the important for the conversations. Therefore, we are integrating our approach, non-verbal communication approach, and their verbal communication approach together. And then by working together, we can make the Android more human-like.
Right. In sociolinguistics, especially, nonverbal communication is extraordinarily important, as prosody and turn-taking, which you had touched on as well. And I guess question that I have is how do you foresee androids developing to situations where they encounter different cultures, different languages, and adapting to those differences in, let's say, prosody, turn-taking, and nonverbal gestures?
That is quite advanced technologies, and I hope to develop that kind of Android which has the learning functions, right? But I don't know when we can do that, right? But first step is to develop the Android that can handle the single language, okay? And then with we can apply that know-how to the different language. I'm naturally Japanese, right? So my first language is Japanese, and then. But after learning the Japanese, I could learn the English, right? So same things happen for the Android. So the Android need to choose the first language, and then Android, can learn the other languages based on that. And probably that is the much faster than human, I guess.
Okay, I think we've covered most of the questions. I do want to, before we close out, I do want to remind everyone that there is a form, a questionnaire that the Embassy of Japan has asked everybody to complete, just to get an idea of how you like the webinar. We've just posted it in the chat. And this is sent from Lina Al-Jadid. If you can see, you can link on it in the chat, in the Zoom. If you're on Facebook, it should be posted in Facebook as well to access. So with that, I would like to thank Professor Hiroshi Ishiguro for your work, for your participation, or your presentation, and it's just fascinating. We've been getting so many comments from folks about how much they've enjoyed your talk, and I would like to thank the ambassador and the Embassy of Japan for arranging this talk for us. And I will, Dr. Lutfi Al-Sharif, if you could please give a final word on behalf of HTU.
If you don't do it, I will.
I believe. Thank you very, very much. Fascinating presentation. Absolutely fascinating. And I wanted to ask questions, but there are so many questions in there. So I think we really thank you for this exciting presentation. I'm sure it's very inspiring for the students and for the staff. So thank you very much. Thank you for giving us this opportunity.
And thank you all. Thank you for all of the folks who've worked behind the scenes, for all of the tech folks who've put the Zoom and the Facebook together, and for my assistant, Lina Al-Jadid, who's amazing, coordinating everything, and for the folks at the Japanese embassy who have arranged the meetings as well. We have Mr. Moroka Fuki and Ms. Sarah Voroka. I want to thank them for their efforts. Again, Professor Ishiguro, thank you so much, and we look forward to you visiting HTU someday, hopefully very soon. This concludes our lecture for today. thank you all for joining us.
Thank you very much.